Good day everybody. The topic of this tutorial video is percentages. And the subtopic is Introduction to Percentages. I am Lamidi. After watching this video, you should be able to understand the basic concepts of percentages and the interrelationships that exist between percentages, fractions, and decimals. So the lesson objectives are to understand the equivalence between fractions, decimals, and percentages, also to increase or decrease a quantity by percentage, and to evaluate one number as an approximate percentage of another, and lastly to solve problems involving percentages. So since fractions, decimals, and percentages are interrelated topics, you may need to refer to the previous videos on the two topics for better understanding of this topic. So let's have a look at the definition of terms. Percentages. Percentage is a way of expressing a quantity as a fraction whose denominator is 100. So the symbol percent is used to denote percentage, which simply stands for per, which means out of 100 is cent. So per, out of cent, 100. So let's have an example to make the explanation clearer. 30% can simply be rewritten as 30 over 100, and with that the zeros will cancel out and you have 3 over 10, and which is equal to 0.3. So if you can observe from here, a number expressed here as a percentage, and it was also expressed as a fraction here and as a decimal. So that shows that percentage, fractions, and decimals you could convert from any form to the other, and as such the three topics are interrelated. So percentage is one of the three major ways of expressing a value. So fractions, decimals, and percentage. We discussed fractions and decimals in details in the previous videos. So in this video we are going to discuss percentages also in details, and as a result we would refer to some of the previously explained concepts under fractions and decimal videos. So let's have a look at an example. 17% has the same value as, so the solution, 17% here is a number expressed as a percentage, and here you have it as a fraction, and here as a decimal. So you could confirm the value using your calculator. The details will be explained as we proceed with this video. So expressing a fraction as a percentage. So 3 over 7 means 3 out of 7 equal parts. So when you see 3 over 7, so it can be likened to having 3 out of 7 equal parts. Also 4 over 10 similarly means 4 parts out of 10 equal parts. So 29 over 100 means 29 parts out of 100 equal parts. So a fraction whose denominator is 100 is read as percent, which implies that 29 over 100 is read as 29%. So now any fraction, when you have a fraction with the denominator of 100, then it's simply you could simply write it as a percentage by writing the numerator and then putting the percentage sign after, just like what has been done here. 29 over 100 is simply 29, then the 1 over 100 here is percent, so we just put 29%. So a fraction whose denominator is 100 is read as percent. So let's refer to some of the previously explained concepts under fractions for better understanding of this concept. So if you could recall from the previous video on fraction, in order for us to evaluate 3 over 5 plus 1 over 2, for instance, we first converted each fraction to equivalent fractions with a common denominator. A common denominator which will be the LCM of the two denominators, and in this case the LCM of 2 and 5 is 10. So we rewrote each of these fractions such that they will each of the two will have a denominator of 10, which is the LCM of the two denominators. So now, to achieve that, what we'll do is we'll multiply 3 times 2, which is 6, and 5 times 2, which is 10, because here to convert this denominator 5 here to 10, you simply multiply by 2, and once you multiply by 2 here, you also have to multiply by 2 so that the number remains the same. So the 2 could still cancel out and you have 3 over 5. So once you multiply the denominator by 2, so you do the same for the numerator to keep the fraction the same. So when you multiply 3 times 2, you have 6. When you multiply 5 and 2, you have 10. Also for the second fraction, 2 will multiply by 5 to have 10 at the denominator, which means you multiply both the numerator and the denominator by 5 each. So when you do by doing that, you could also cancel out 5 and you have 1 over 2. So we've not actually changed anything about the fraction. So just like re-expressing it for easy simplification. So 1 times 5 is 5 and 2 times 5 is 10. So just as we've done here, trying to solve add two fractions by changing the denominator to the LCM of the denominators of the two fractions, we could in the same way change each of the denominators into 100, just as we've done here. So you simply look for what to multiply 5 by to have 100, so which is 20, because 20 times 5 is 100. So when you multiply 5 here by 20, it means you also multiply the numerator by 20, so that will keep the fraction the same. So you could also cancel out 20 and you have 3 over 5. So when you multiply 3 times 20, you have 60, and when you multiply 5 and 20, you have 100. So now you have 60 over 100. And remember from the previous slide where we explained that a fraction whose denominator is 100 is read as percent. So here now, since we have the denominator here as 100, so it means 60 over 100 here, we could express it as 60% because the denominator is 100. So similarly here, to rewrite this fraction to such that the denominator will be 100, so we simply multiply the 2 by 50, and when we do that, we multiply both the numerator and denominator by 50. So 50 times 1 is 50, and 50 times 2 is 100. And now, since the denominator here is 100, so a fraction with the denominator of 100 is a percentage. So now 50 over 100 is simply 50%. So alternatively, another way of achieving the expression of a fraction as percentage is to write a fraction then multiplying by simply by multiplying a fraction by 100%. So as in here, 3 over 5 is simply 3 over 5 times 100%, and when you do that, so the 5 here, when you divide 5 by 5, you have 1. When you divide 100 by 5, you have 20. So 3 times 20, you have 60. So the percentage remains, so you have 60%. So you could use any of those two methods, but here the method here is more simpler. Here what has been done is to make the concept clearer, but to achieve that simply, since you will be given a time which may not be enough in your JAMB examination, so you could use this method to make things easier. So when you have a fraction to be expressed as a percentage, you simply multiply by 100% and you have it as a percentage. So now, doing the reverse, expressing a percent as a fraction. So to write the percent as a fraction, we simply drop the percentage sign and multiply the number by 1 over 100, or simply dividing the number by 100. So when you multiply a number by 1 over 100, it is the same as dividing the number by 100, because when you multiply 1 by the number remains. So then you simplify. So for example, 37% here, you write the number 37, then you multiply by 1 over 100. So the 1 over 100 here represents percentage. So then you now simplify. So 37 times 1 is 37, then 100, the denominator remain, because 37 here is like writing 37 all over 1. So you have 37 over 100. Also, 25% is simply 25 times 1 over 100, which is the percent. So when you do that, you could now simplify, and here you could divide 25 by 25 to have 1, and 100 by 25 to have 4. So you have it as 1 over 4. So 25% is, you could write it as a fraction 1 over 4. So now, conversion of decimals to percent. So having discussed the conversion of fractions to percentages and conversion of percentages to fractions, so now we are going to discuss how to convert decimals into percentage. So to write a decimal number in percent, we simply move the decimal point 2 places to the right and put the percentage sign, and this is the same as multiplying by 100%. So here, let's have some examples to make the statement clear. 0.36 in percent is simply 0.36 times 100%, which is 36%. And moving 2 places to the right is just like moving the decimal point here 1, 2, because you have 2 zeros after 1, so it's like 36%. So 0.36 times 100% is 36%. So you either multiply by 100% or simply move the decimal point 2 places 1, 2. So similarly, 5.3% could be done by simply multiplying by 100% or moving the decimal point 2 places to the right. So 1, so you have 53.0 here, so which is not shown. Then when you move once again, so you have 530, which is 530%. The percentage remains. So now, doing the reverse, expressing percent as a decimal number. To express percent as a decimal number, you simply drop the percentage sign and insert or move the decimal point 2 places to the right, to the left in this case. In the case of conversion of a decimal number into percent, you move, we moved the decimal point 2 places to the right. So in this case, we move 2 places to the left because we are reducing the number. When you multiply by 1 over 100, it's like dividing a number by 100, so you are reducing the number, like multiplying by 100, which increases the number. So here, let's have examples to make the concept clearer. 43% as a decimal number is simply 43 over 100, since the percentage here is 1 over 100. So when you do this, so you simply move, so 43 the decimal point 2 places to the left. So 43 here is simply 43.0, and when you move decimal point, so in the first place you have 4.3, and the second you have 0.43. So and that's how we arrive at the 0.43 here. So you could use your calculator to check. and you arrive at 0.43. So another example, 75% as a decimal number. So the percentage here is 1 over 100, so you simply multiply 75 by 1 over 100, so you arrive at 75 over 100, which is 0.75. So you simply, here is 75.0, so you simply move the decimal point 2 places to the left. So the first place you have 7.5, and the second place you have 0.75. So 75% as a decimal number is simply 0.75. Also, the third example, 12% as a decimal number is simply 12 over 100. So when you move decimal point 2 places to the left, 1, 2, so you have 0.12. So let's have a look at another important concept, which is increasing the quantity by percentage. I want my dear viewer to pay close attention to the concepts which will be discussed here, as this is because most of the applications of percentages make use of this concept. So once you understand this concept clearly, the understanding the applications of percentages won't be a problem. They will become easier. So having said all this, let's go into the details. So an original quantity is 100%. So when you have an orange, so that represents 100% of the orange. So when you cut a part off from the orange, so what you have will be less than 100% of an orange. So similarly, so when you decrease a quantity by a percentage, your result will be less than 100% of that quantity. And when you increase the quantity by 100%, your result will be more than 100% of the quantity. So let's have some examples to further clarify the concepts. So increase 60 pound by 25%. So now when we increase 60 pound by 25% from the explanation, that means what you arrive at will be more than 60 pound. So now, so we could solve this by first finding out the 25% of 60 pound. So when you do that, these zeros will cancel out, and you could 5 divided by 10, you have 10 divided by 5, you have 2, and 25 divided by 5, you have 5, and then 2 in 2, you have 1, and 2 in 6, you have 3. So 5 times 3, so you have 15 pound. So this is the amount that 60 pound has been increased by. So now that means, and from the explanation given, when you increase 60 pound by 25%, the quantity what you arrive at will be more than 60 pound. So now that means this is the increment which was introduced by increasing 60 pound by 25%. So now to now get the increased value, you simply add the 25% of 60 pound, which is 15 pound, to 60 pound. So when you add 15 pound plus 60 pound, you have your result as 75 pound, which is more than 100% of the 100% value, which is 60 pound. So alternatively, you could work out percentage increase in a single calculation. So to make things more easier, especially under examination condition, 100%. So we've been asked to increase the 60 pound by 25%. So since 60 pound represents 100% of the quantity, so now increasing it by 25% means adding, so having 100% plus 25% of it, which is equal to 125% of the quantity. So now the quantity given is 60 pounds. So now we now simply evaluate 125% of 60 pounds, and when you do that, the zeros here will cancel out, and when you simplify, you arrive at 25 pounds times 3, which is 75 pounds. So as you can see here, the method here, using the method in this alternative method, the problem has been simply solved using a less number of calculation steps. So under examination condition, this method will save a lot of time. So let's have a look at another subheading, which is decreasing the quantity by percentage. So to decrease when you decrease the quantity by percentage, so when you arrive at to be less than 100% of that quantity. This has been explained in the previous slide. So let's have an example. Decrease 80 by 75%. So we can first find the 75% of 80. So we are decreasing by 75%. So the decrease is 75% of 80. So which is 75 over 100 times 80. So when you simplify this, you have 60. So this is the decrease, which is the amount by which 80 has been decreased. So now, since the decreased number will be less than 80, which means you subtract 60 from 80. So when you subtract 60 from 80, you have 20. So when you decrease 80 by 75%, so what you arrive at is 20. So alternatively, using a single calculation and a less number of steps, when decreasing 100% of the value, which is 80, by 75%, so you simply subtract the 75% from 100% of the value, so you arrive at 25%. So you now take 25% of the quantity, which is 80, and when you do that, you arrive at 20. So now let's have a look at another important heading: determination of percentage of x in n set of items. So to determine the percentage of x in a given n set of items, we simply divide x by n and multiply the result by 100. So simply, when to have percentage of x in a given n set, you simply divide x by n and you multiply the result by 100%. So when you multiply the result by 100, so you have percentage of x in n sets of items. So let's have some examples. Mr. XYZ obtained 42 marks in a test of 50 marks. What was his percentage of marks? So now the total marks which is obtainable is 50, and now the mark obtained by Mr. XYZ is 42. So the fraction of marks obtained is equal to the marks obtained divided by total number of marks, so which is 42 over 50. So in percentage, to express this fraction in percentage, we express the fraction such that the denominator will be 100. So to do this, multiply both the numerator and denominator by 2. So I have for 2 times 2, which is 84, and 50 times 2, which is 100. So we arrive at 84%. So marked alternatively, using the relation given here, marks obtained in percent is marks obtained divided by total number of marks times 100%, which gives us 84%. Let's have another example. Out of 60 students in the class, 15 opted to go for an excursion. What percent of students opted for excursion? So the solution. So let's take n to be the total number of students in the class, and from the question it was given that 60 students are in the class. So n equals to 60, and let's also take x so to be the total number of students that opted for excursion, and as given in the question, 15 students opted for excursion, so x equals to 15. So the percentage of students that opted for excursion is equal to the total number of students that opted for excursion divided by total number of students in the class, which is x over n times 100%. So the percentage of students that opted for excursion is equal to 15, which is the number of students that opted for excursion, divided by the total number of students in the class times 100. So 100%, which is 1 over 4 times 100%, which is equals to 25%. So let's have another example. What percent of 90 is 15? So here, normally we should solve using the relationship which was given here, but let's try and solve the problem first by simply interpreting and understanding fully what the question is. So what percent of 90 is 15? Since the percent is unknown, let's represent it with x. So let the percentage be x. So this implies that x percent of 90 in what now equals to 15. So since the office time is a multiplication sign, so and the percentage represents 1 over 100, so you simply write x over 100 times 90 equals to 15. So by making x the subject of the formula, we have 15 over 90 times 100 equals to x, and 15 divided by 15 you have 1, 15 divided by 90 you have 6, so x equals to 1 over 6 times 100%, which is equals to 16.67%. So as you can observe from this step, although we didn't start by simply substituting into the formula, but we've arrived at the substituted expression. So it's always important in mathematics to understand what the question means before laying hands upon them. When you do that, it makes solving mathematical problems very easier. So this also applies to other courses. You try and understand the question first before laying hands upon them. So the answer in this example is approximately 16.67%. So applications of percentages. The major applications of percentages which we are interested in this video series are percentage change and percentage errors, profit and loss percent, simple interest, and compound interest. These three topics are applications of the concept of percentages in business scenarios, while these find application mostly in science, especially when dealing with experiments and all that. So these applications will be discussed in details as we proceed. So let's have some sample questions. So sample question 1. This question is from UTME 2014. A man donates 10% of his monthly net earnings to his church. If it amounts to 4,500, what is his monthly income? So the score booster solution is now 10% of his monthly income, monthly net earnings was donated to church, and 10% of his monthly income amounts to 4,500 naira. So we are required to calculate his monthly income. So since the monthly income is unknown, let's represent it with M. So let his monthly income be M. So 10% of M now is equals to 4,500 naira. So since it was given that 10% of his monthly income M is equal to 4,500, so and since the percentage sign represents 1 over 100, so 10% is simply 10 over 100. So this implies 10 over 100 times M equals to 4,500. Since the off is it means multiplication, so making M the subject here, we have M equals to 4,500 times 100 divided by 10. So the zeros here will cancel out. You simply have the answer to be 4,500 times 10. So M equals to 45,000 naira. So always remember the units, it's in naira. So let's have another sample question. Sample question number 2. If the population of the town was 240,000 in 1998 and it increased by 2% each year, what would be the population of the town in January 2000? This question is from UME year 2000, and this covers the solution now. So it was given that the population of the town was 240,000 in 1998 and each year it increased by 2%. So in January 1998, the town population was 240,000 as given. So in January 1999, the town population will be 240,000 plus 2% of 240,000, which is 240,000 plus the increment, which is 2% of 240,000. So here this evaluation is for the increment 2% of 240,000 plus 240,000. So since 240,000 has been increased by 2%, so you have 240,000 plus 2% of it, which is 240,000 plus 4,800. This term which has been shown here, when you simplify you get 4,800. So when you add 40,000 and 4,800, so you arrive at 244,800 in January 1999. So the population in January 1999 is 244,800. And now we are asked to determine the population in January in the year 2000. And also note that we've taken January here since it was stated in the question that January we were asked to find the population in the month of January. So we start our year also from January each year. So in the year 2000 now, the town population will be the population of the town in January 1999 plus 2% of the town population in January 1999. So this is the population of the town in 1999 that was calculated here. So 2% of it, when you evaluate this, you have 4,896. So we now simply add to the population in January 1999 to arrive at the population of the town in January year 2000. So which means when you evaluate this, you have 244,800 plus 4,896, which is equal to 249,696. So So let's have a look at the following practice questions. The questions are from past JAMB examination papers. So viewers are advised to try and solve the problems on their own before going through the ScoreBooster solutions. So let's have a look at the solutions to the practice questions. So practice question 1. The worker's present salary is 24,000 naira per annum. His annual increment is 10% of his basic salary. What will be his annual salary at the beginning of the third year? This question is from UNE 1995. So the ScoreBooster solution. Since the worker's present salary is 24,000 and the salary is increased by 10% of his basic salary annually, which means every year. So we are asked to determine his annual salary at the beginning of the third year. So the present salary is 24,000 per annum. So at the beginning of the first year, the salary is 24,000. Here it was given that we were asked to calculate the annual salary at the beginning of the third year. So we start counting from the beginning of the first year. So at the beginning of the first year, the salary is 24,000 naira. So at the beginning of the second year, since the annual increment is 10%, so the new salary will be 100 plus 10%, which gives us 110% of 24,000. So the salary at the beginning of the second year is 110 divided by 100, since the percentage sign here represents 1 over 100. So you have 110 over 100 times 24,000, which is equals to 26,400. So this is the salary at the beginning of the second year. So at the beginning of the third year now, the annual salary, the salary now is also, it will also increase by 10%. So the new salary at the beginning of the third year will be 110% of the salary at the beginning of the second year, so which is 26,400. So we have 110% of 26,400, so which equals to 110 over 100 times 26,400, which is equals to 29,040. So the salary at the beginning of the third year is 29,040. So let's look at the solution to the practice question 2. A man earns 3,500 naira per month, out of which he spends 15% on his children's education. If he spends additional 1,950 on food, how much does he have left? This question is from UTME 2012. And let's have a look at the ScoreBooster solution. So the man earnings in the month is 3,500 naira. So this is the man's earnings, monthly earnings, and now he spends 15% on his children's education and 1,950 on food. So the man, as can be observed from the question, the man runs to expenses, which is education expenses and also food expenses. So now, since the earnings in the month is 35 and 15% of the earnings is on the children's education expenses, so the actual value of the education expenses in naira is 15% of the salary, which is 15 over 100 times 3,500, which is equals to 525 naira. So now the second expense is the feeding expenses, which is given as 1,950 naira. So the total expenses of the man is the feeding expenses for the plus the education expenses, and the two, it will, by adding the two, will arrive at 2,475 naira. So the amount left will be the earnings per month minus the total expenses incurred. So the total monthly earnings is 3,500, and the expenses incurred is equal to 2,475. So 2,475 minus 3,500 equals to 1,025, which is the amount left, and that is what we've been asked to calculate in the question. So the answer is 1,025 naira. So let's look at the last practice question. A cinema hall contains a certain number of people. If 22.5% are children, 47.5% are men, and 84 are women, find the number of men in the hall. This question is from UME 2003, and let's go through the ScoreBooster solution. So, as given in the question, the hall contains three categories of people, which are children, men, and women. So the percentage of children plus the percentage of men plus the percentage of women will give 100% of the people in the hall. So now, since percentage of children is given as 22.5%, and that of the men is given as 47.5%, so which means the total percentage of children and men altogether is 22.5% plus 47.5% of the total number of people, which is 70% of the total number of people. So, and since children and men already form 70% of the total number of people, that implies that the remaining 30%, which is 100% minus 70%, the remaining 30% will be women. So let W be the percentage of women. So if 70% of the people are children and men, so 70%, which are children and men, plus the percentage of women is 100%. So the percentage of women is 100% minus 70%, which is 30%. So if since each person will occupy a seat in the hall, so this means there are 84 women in the hall, which means 84 people in the hall gives 30% of the total population. And since both all women, men, and children are all classified as people, and don't forget the assumption which have been made in solving this question is that each of the children, men, and women, which are the categories of people in the hall, will occupy a seat. So it means 84 people in the hall represent 30% of the total. So let the total number of people be A. So 30% of the total number of people is 84, which means making N the subject A and replacing off with a multiplication sign, you have N equals to 84 times 100 divided by 30, which is equals to 280 people in the hall. Thank you for watching this video.